Hello, hope you're doing great. My name is Shazad Ali Hassan, and this is the homework assignment for finding the z of x and y, z of y for the Lorenz equations, for which the initial conditions are x equals 1, y equals 0, and z equals 20. Um, Let me walk you through the code. So the first one is using the Euler method. This function, this one is just calculating the derivative for x, y, and z and returning the value of derivation of x, y, and z. This function takes the initial values of x, y, z and the sigma, rho, and beta. I have defined all of the variables here. So this step that the difference of step is 0.01. The number of steps is 10,000 iterations. X, Y, Z are initially an empty array that just go to one additional index to 10,000. We are not using time anymore. This These are the initial conditions that were provided in the question. This is the Euler forward method, in which the next value of the function depends on the initial value plus the differential into the time difference, which is 0.01, and this gives us the values of x, y, and z. Both x, y, and z are uh, matrices, and these are row matrices of 1001 height. And this simply plots the graph. Let me run the code. All right. So, so this one is z plotted with respect to x, and this one is z plotted with respect to y. I have also written the code to plot the 3D graph. And just run this one to just see the 3D image of the same equation using the Euler method. This is not the part of the code, but I have just written it there. So if you want to see, you can have a look at that. Right. And now let's move to the other one, which is the same code, but using the predictor corrector method. So what I did here, so for the predictor method, we were going from instead of directly calculating the I plus 1, we have to calculate I plus 1.5. So that means we are going to find the middle point. But these are the array, and I tried using 1.5, but it was giving me an error that indexes cannot be 1 plus half. So instead of going for x I plus 2, which would have caused me another error, and I would have to increase the number of arrays here, I just rewritten the value of the all the conditions for x plus 1 here. Uh, so what this one is doing, this is just calculating the values of the midpoints of x, y, and z, and then this one is finally calculating the values of uh, x plus 1, y plus 1, and z plus 1. These here, this line, this is calculating the derivatives of these values that we have here. And this one is simply plotting the graph again. Let me run this for you. Right. So this is pretty much the same one, but I think that the Euler ones is a little more accurate. I have one more file, if I believe. I will make sure to link that. So in that one, I have just made sure that both of the codes are in one file and we don't have to open two separate files for the same thing. I will make sure to link both of the blog posts there. You can find it. The code is on the GitHub repo for the same one, and the other one is also on the website. If you will go to the GitHub repo, you can switch to the branch for homework 1, the SOR code, and homework 2 for the Euler method or the other one. So in second branch, I think I have all the three files. For Euler method, this one contains both the files, the predictor method and the Euler ones. Let me just show you. This is pretty much the same code, but for uh, Euler, I have used X, Y, and Z, and for the predictor method, I have used PCX, PC for predictor counter. So yeah, thank you so much.